Hello, everyone. This is Professor DePaulo. Welcome you back to Psych 220 Behavioral Statistics. Today, I'm going to go through another ANOVA problem just to get you to have a little bit more experience doing ANOVA. So, in this problem, we are looking at an herbal product that improves memory. So, this herbal product claims to improve memory. Various dosages of this herbal product are given out, and memory is measured by the number of items on a list of words that are recalled. So this is another basic memory task where we are presenting a list of words to somebody and then testing them at a later time to see how many of those words do they remember. And so the idea is this herbal product will increase memory, and people that take more of the product will basically remember more, right? And so this experiment has three groups. It has a placebo group. These are the number of items on the list recalled. It has a 25 milligram group, and these are their scores. And it has a 50 milligram group, and these are the scores of the 50 milligram group. So, does this herbal product increase in memory? There are 15 participants. 5 of them are randomly assigned to get placebo. 5 of them randomly assigned to get 25 milligrams of this herbal product. And 5 people are randomly assigned to get 50 milligrams of this herbal product. So the first thing we have to do is we need to square everything, right? So this is, x1, this is x2, this is x3, and then we need an x1 squared, right? So we're going to square all of this. And then we're going to square the x2 values. And then we're going to square the x3 values. So we're just squaring everything first. Now that you have the 6 columns set up, you're going to add up all 6 columns. So add up all 6 columns here. Once you get all 6 columns up, the next step is to find the grand mean. So the grand mean is just the 3 non-squared columns, the sum of the 3 non-squared columns. So it's going to be 23 plus 26 plus 29. That's going to give me 78. So that's the grand total, not the grand mean, obviously. Grand total, the sum of the 3 non-squared columns. And then we're going to have a sum of x squared column. Let me write that a little bit better for you. Oops, that's the problem with these tablets is you can accidentally click on something. Put it back like this. The sum of x squared looks like this. And this is the sum of the squared totals, right? So it's 111 plus 146 plus 175, and that sum of x squared becomes 432. So now we are set up. Now we are prepared to start the problem. So this was just setting up the problem. Now we're going to actually execute the problem. So what we want to do here, sorry, I'm just trying to transition. Move this away, out of the way. And we're going to start with that. Okay. So we're going to do sum of squares total. That's going to be equal to the sum of x squared minus g squared over capital N. Now capital N here is the sample size, so it's 15. And then the lowercase n's are going to be the sample size for each group. So capital N is the total sample size at 15. So sum of x squared is 432. We have that already. We just have that here. Minus g, we have a 78. Square that, put it over n, which is 15, the total sample size. And when we simplify that, we get 26.4. So that is going to be our sum of squares total. Now let's do sum of squares within. This is going to be equal to the sum of squares within each of these three groups, which we know is going to be the sum of x squared sub 1 minus the sum of x sub 1 squared over n sub 1, right? Plus, we're doing the sum of squares for each of these three separately. The sum of x sub 2 squared minus the sum of x sub 2 quantity squared over n sub 2. And then we're going to do the third one, of course, and that's going to be the sum of x sub 3 squared minus the sum of x sub 3 quantity squared over n3. So we're now going to move that up even more, and we're going to solve it. So let's start with group 1. We have 111. So I'll just put brackets to keep everything separate. Minus 23 squared over 5. For group 2, we have 146 minus 26 squared over 5. And for group 3, we have 175 minus 29 squared. So I'm finding the sum of squares for each of the three groups. So that simplifies to give me 5.2 plus 10.8 plus 6.8. And that sum of squares within is going to be 22.8. So once I do those three groups, I come up with 22.8 as my sum of squares within. Now to get sum of squares between, we just subtract. So sum of squares between is going to be the sum of squares total minus sum of squares within, which is 22.8. And that gives me 3.6 as my sum of squares between. We know that my degrees of freedom between, again, is equal to k minus 1. In this case, it's 3 minus 1 of 2. And my degrees of freedom within is going to be equal to n minus k. N is 15, k is 3. So degrees of freedom within is 12. Now I can set up my mean squares between as equal to my sum of squares between divided by my degrees of freedom between, and that gives me 1.8. And my mean squares within is my sum of squares within, 22.8, divided by degrees of freedom within, which is 12. 22.8 over 12 gives me 1.9. And my F ratio is going to be 1.8 divided by 1.9, which is equal to 0.95. Now, I don't really need to test this to the critical value. This value is less than 1, which basically is way far away from what F needs to be significant. So I can tell you right now, this is not going to be significant because it's less than 1. When the null is true, the F is around 1, and this is almost exactly 1. However, we can look up the critical value if we so choose. Our degrees of freedom are 2 and 12. So let's look up the critical value. And we're going to go here. Let's go into the table in bright space to find the critical value. So I'm in the table in bright space and I'm finding the critical value here. So this would be under, let's see. Jobs and materials, we're going to study guides, and you have final exam formulas and tables. We're then going to look up the F distribution with 2 and 12 degrees of freedom. We're going to use alpha of 0.05 here. So 2 between, 12 within, and we get 3.88. That's a common one we've been getting a lot. 3.88 as our critical value. And we're back to the whiteboard, 3.88. So the F critical for 2 and 12 degrees of freedom is 3.88. Obviously, our F obtained is 0.95. This obtained value is not more extreme than the critical value. So shockingly, we are failing to reject the null. So here we fail to reject the null because our obtained value is 0.95. Our critical value is 3.88. Obtained value is not greater than the critical value, so we fail to reject the null here. If you want to draw it, you can draw the F like this, right? It's a positively skewed distribution. Here's our critical, 3.88, and our obtained is going to be way in here, 0.95. So therefore, it's not in the tail, so we fail to reject. So do we want to run post hoc tests? No, do not run post hoc tests if we fail to reject the null, because the null says that all the groups are the same. So it says that placebo, the 25 milligram group, and the 50 milligram group are all the same. The alternative says they're not all the same. If we fail to reject the null, we have to conclude that all the means of the three group means are the same. And if the 3 group means are the same, then we have no need to look for differences between group means. So we do not need to run post hoc tests here. We're done with the run. Fail to reject the null, there's your F value. That's it. Game over. So this is an example of ANOVA where we're failing to reject the null. A little bit less work because we don't have to do the post hoc test, but this is not what we generally want to happen because we want to support the alternative because that's the research hypothesis. That's what we think is going to happen. We want to happen. And when we fail to reject the null, we say that we're wrong, basically. So that's it for doing an ANOVA here with a non-significant F value. Hopefully that helps. And if you have any last minute questions, you can always email me. And I'll see you for the final exam in a couple of days. Bye for now.